Hey everyone, Tom here, and IGUS recently sent me this insane sample package, and I would like to take this opportunity to talk about whether or not, when and how you should be using these over regular linear ball bearings. So, for example, in an LM8UU linear ball bearing, there are recirculating bearing balls, so you never end up with an actual sliding surface to bear any loads. It's always a macroscopic steel ball that does rolling. In a lubricated bushing, the lubricant itself takes that roll of the steel balls and acts as a microscopic interference layer between the two sliding surfaces. And it doesn't matter whether they are rotating or linear slides, it's the same principles. Now, brass bushings or these IGUS dryland polymer bushings take a bit of a special position here, as the bushings themselves are the lubricant as well. Brass bushings are typically sintered and oil impregnated, so as they slide, they deposit tiny amounts of oil into the sliding contact and lubricate it that way, or as a backup, plain brass also slides on steel reasonably well, even without a lubricant. But of course, it wears down much faster when there's no interference layer between the mating parts. Actual self-lubricating polymer bushings like the IGUS types work in much of the same way. They deposit a lubricant that is an integral part of the polymer blend, and you can actually feel your fingers getting all slippery and stuff when you play around with a dryland bearing that's sitting on your desk. How do I know that? Well, what do you think I've been doing while I was scripting this video? What that means is that in order to function, there needs to be a tiny amount of abrasion happening so that the actual lubricant can work where it needs to be. So a polymer bushing will degrade during its service life and gradually gain more internal clearance and consequently increased play as it ages. After a quick go at it with the IGUS bearing life calculator in an i3-ish configuration for its x-axis, it does match up with my experience, which is basically they will last forever in that application, with an expected service life easily past several thousands of prints. And when they do fail, it won't be like an LM8UU that just randomly starts locking up. The polymer bushings will keep working just fine, albeit with a slightly increased slop. Now, if you've seen them in actual use before, you'll most definitely have noticed that they are already loose like sleeve of wizard, even when they are factory new. But so are cheap LM8UU bearings. Like that, you can just wobble them around. Still, it's one of the main reasons why people recommend against using polymer bushings. Okay, so ideally you want a tiny amount of pre-tensioning in your bearing. In a decent LM8UU or Hywin MGN rail, that is generated by the linear shaft or mating surface being ever so slightly oversized for the bearing, and that will have the actual bearing case ever so slightly deform and act as a very stiff spring. And for an LM8UU, that's this steel sleeve you see from the outside, which the balls roll against on the inside. In a polymer bushing, the bushing itself can compress and deform to achieve that. However, due to how these bushings are manufactured, they are intended to be used in an interference fit with a slight press fit as you install them. So not just loose zip tied to some holder, but actually pressed into a tightly tolerated bore with a 40 kilogram force. And when you do so, these assume their final tolerance with regard to the linear shaft. So actually, if used correctly, the common R-jump type these are specified for a maximum of roughly 50 microns of play. If used on popular linear shafts like IGUS's own anodized aluminum ones or the common chrome linear shafts that you would use for a linear ball bearing, which are actually not that great for polymer bushings, stay tuned. So you're never going to get any actual pre-tensioning with these linear polymer bushing inserts. That's just not how they are designed. But if you use them properly, you'll get a very respectably low amount of play. It's just that it's kind of hard to really use them that way on a 3D printer unless you're actually using precision machined aluminum or steel parts, and trying to get that press fit H7 tolerated board just right with common tools is pretty close to impossible. IGUS does offer these RJUM bearings, which come with a massive aluminum sleeve, so you can use them exactly like LMUU bearings. But they are pretty expensive, and you could easily buy a brand name LMUU bearing for the same price. Now, if you're designing a printer from scratch and are set on using polymer bearings, then there are other options available, like these simple N-series slides that have ever so slightly pre-tension sled available for them. But of course, once you apply the tiniest amount of force, that pre-tension stops being effective. Or you could use these adjustable slide blocks like this one on the W types. This concept really is similar to the adjustable linear ball bearings, so really you could achieve the same effect with either one if you want discrete bearing blocks. These W-type rails fall into the same category as the Highwind MGN rails, which you can order with 0 bearing play, and for that reason they are pretty much considered the king of linear slides. You do have to be a bit more careful with dust and contamination as with any ball bearing, but that's typically not much of an issue in FDM-based 3D printers anyways. The IGUS dryland bearings are pretty much immune against dust and dirt. You know, there are no super small moving parts that would get shredded if any foreign object made its way in. One thing polymer slide bearings or even brass bushings excel at is noise, especially when compared against cheap LMUU bearings. Because there are no moving parts, there really is no noticeable noise. And what's great is that it doesn't depend on you mounting them perfectly in line. If you've ever had the joy of trying to line up a pair of caged LM8UU, also known as SC8UU, you'll know that if you ever so slightly misalign them, they're going to sound like they are grinding away your linear shaft. And they are. I mean, it's super easy to mar your linear shafts just by running a misaligned LM8UU up and down once. Now, if you misalign polymer bushings, they aren't going to run perfectly either. They will stick and squeak, but they aren't going to break anything. Still, aligning them is one of the tricky bits. For these polymer bushings, you don't really need any sort of special linear rod. Sure, it should be a precision rod with good tolerance on its diameter, but if you can only get plain ground stainless steel rods, then those will work just as well. IGUS even offer these anodized aluminum wheels, which of course are a bit less stiff than steel, but you can compensate for that by going for a slightly larger size. So overall, those can get you some weight savings, which might help you out if you have a moving rod setup like in an H-bot. One more thing I want to point out is that polymer bushings definitely feel different to linear ball bearings when you try them outside of a printer. They are still very smooth, but you can definitely feel them having a bit of drag as you move them along. Now, that is not necessarily a bad thing. You see, the main load on a 3D printer stepper motor is going to be dynamic, so from the inertia of the carriage, it's pulling. If you add a bit of dampening to that axis, which the slide bearing drag essentially is, then you're not going to see any performance hit when it comes to achievable top speed. But you might actually see a reduction in any sort of oscillation artifacts. Granted, I'd still need to test how much of a difference it actually makes, if any, but you know, just to get that out of the way. And I've looked this up specifically for the IGUS bushings. You can also add lithium grease to the rails to support the bushing's natural lubricant if you want them to glide along a bit more easily. So in conclusion, when should you be using polymer slides over ball bearings? Well, what it comes down to is whether you want and can spend a bit extra time and money on mounting them properly and possibly using the aluminum caged ones. But once you get them lined up properly once, they are going to give you basically an infinite service life in a 3D printer application. You don't need to be particularly careful with these rails or worry about any sort of oil or grease that might need to be reapplied periodically. And while from a precision standpoint, Highwind MGN rails are probably the better choice all around, they aren't quite as foolproof once out in the field, and of course require the printer to be designed specifically for these rails. If you're looking to upgrade from LMUU bearings, again you'll probably want the aluminum case version, but those should be a direct drop in replacement in most cases for a quieter and more reliable machine. Alright, I hope that clarified a few things. If you've got your own experiences with IGUS bushings, share them in the comments below. Other than that, get subscribed and have a look at my Patreon campaign. Links for those are in the video description below. As always, thanks for watching, and I'll see you in the next one.